My name is Oliver and I will be doing the CAPB assignment with my team. I will be doing question 1, Roman 1 and Roman 2. Before I start I would like to introduce my members list, which consists of Lee Kai Sian, Oliver Blessing, which is myself, Muhammad Azrul, and Rigneshwaran. These are the list of contents of the questions, starting from question 1 all the way to question 2. Question 1. Before I start I would like to read the background of question 1A. A computer architecture student taking part in a lab simulation of a Motorola 68K microprocessor using Easy68K simulator to help him understand how data is accessed in memory or through registers. Using Easy68K, he is tasked to write examples program of a basic arithmetic program that uses different addressing modes. The examples of program should contain move, add, and sub instructions and commands. Roman 1. Define addressing mode. An addressing mode is the method a processor uses to locate or access the operand. So basically, it tells the instruction where the address is. Roman 2. List all the addressing modes in M68K processor. There are a total of 12 addressing modes. So the first one is data register direct addressing. The operand is in a data register starting from D0 all the way to D7. It is the fastest and no memory access. 2. The address register direct addressing. The operand is in an address register starting from A0 to A7. It's only for addressing, not arithmetic, and but exemption is allowed for A7 for stack. The third one is address register indirect. It uses the address in N to access memory. For example, A1. It access memory at address stored in A1. The fourth one is address register indirect with post increment. It uses address in N, then increments N after access. It's common in loops or moving through arrays. The fifth one is address register indirect with pre-decrement. The decrement N first, then uses the new address. It is often used for pushing to stack. The sixth one is address register indirect with displacement. It adds a 16-bit displacement to the address register. For example, there is 4 and A2. The effective address is A2 plus 4. The seventh one is address register indirect with index and displacement. It combines base address N, 8-bit displacement, and index register. For example, xn equals to dn or n, that's the formula. For example, we have 8, A3, and D2. So the EA for this is A3 plus D2 plus 8. For the eighth one is absolute short addressing. It directly uses a 16-bit absolute address in memory, but it is within 64 KB. For example, we have 2000 word. For the ninth one is absolute long addressing. It directly uses a 32-bit address, its full memory range. For example, we have this long word. For the 10th one is the program counter PC relative with displacement. So it adds displacement to the current PC. For example, we have 12 and PC. The EA is PC plus 12. For the 11th one is program counter PC relative with index and displacement. It's like the previous one, but it adds an index register. So for an example, there is 4, PC and D3. So for the EA is PC plus D3 plus 4. And for the last but not least, we have the immediate addressing. The operand is part of the instruction itself. Example, move 5, which is decimal 5 to D0. Thank you.
Hi guys, today I want to present is giving the example of a M6800 assembly program that performs addition from two number using last three number addressing mode. This is the example of the addressing mode check, and this is our doing at the 6A easy. Let's see a video. Easy 68 I download at my laptop and do a program in Easy 68 editor. After that you get the answer 15 because 15 in decimal you can change to hexadecimal FF. Mm, yeah. And the next is giving the example M68 assembly program that perform subtraction from two number using at last three addressing mode. And this is the chat, and this is all the screenshot I do in Easy 68. Let's see the video. And you run up, you get the answer is 7. And that's all for my part. Thank you.